Hi, I'm Vasav and welcome to CoolCube. Alright, so today I'm going to be talking about voltage, and in my opinion, out of the three major beginner things like voltage, resistance, and current, voltage is probably the hardest to understand. So first I'm going to define it in sort of like common terms as something that's easy to understand, then I'll go into the physics part, and I sort of explain in a quick way the physics behind voltage. So just feel free to watch whatever you want. Okay, so first and foremost, what exactly is voltage? So according to Google, the definition of voltage is the electrical potential difference, or the electric pressure. So let me write that out. So this second definition is much easier to understand than the first, and I'll go into the first a bit later, but I'll start with the second one. You can notice that I have these two diagrams below, right? What these are supposed to represent is exactly what voltage does. In this diagram right here, you'll notice that this guy, this tiny green guy, is representing voltage, and he's trying to push current, amps, through this small tunnel, and resistance is trying to stop the amps. And this sort of is what voltage really is. It's the pressure that sort of pushes the electrons through a circuit. You may be wondering, what is a circuit? A circuit is literally just a closed loop that carries electricity. And on the left-hand side, you're gonna see this water tank, right? And in this scenario, the voltage is the pressure of this water tank. The more voltage or pressure you have, the faster the water is gonna shoot out, right? So this measurement right here is just gonna be the voltage. As you can see, that in this circuit, right? Right now it's not closed, it's open. But there are still these electrons here. But now, since there's no voltage, these electrons don't really know what to do. You might be wondering what a load is. In this scenario, a load is just, it can be literally anything. It could be a diode or a resistor, a light bulb. It doesn't need to be anything, so I'm just calling it load. Now, when I move this battery here, that's gonna act as my voltage. What's gonna end up happening is these electrons are going to start moving, right? This depends, so they're going to be moving, this way. I'm not using conventional current, but yeah, conventional voltage, but yeah. So yeah, they're going to be moving this way, and voltage is sort of that force that pushes the electrons through the circuit. So I don't know. In this case, let's say this is what 12. This is what like 12. Yeah, 12 volts, and so that's basically the amount of force or pressure that's pushing these electrons through the circuit. That was pretty much the sort of basic explanation for voltage, and I'm going to go into the more physics-based definition of voltage, so feel free to just stop watching here if you don't need to learn this, but yeah, I just find it interesting to know. If you want me to go more in depth into the physics definition, then just let me know down in the comments. So yeah. So what I want you guys to pay attention to is this definition, the electric potential difference. And to sort of explain all of this, I have this atom right here, this helium atom. So as you can see, there are 2 protons, 2 neutrons, and 2 electrons. So the total charge of this atom is neutral, because the positive charges from the 2 protons, and the negative charges from the 2 electrons cancel out. Now, if I were to say add an electron, then it would be a negative charge, right? -1, or this would become negative because I'm adding an extra electron, and that sort of disbalances this, right? So just keep that in mind, right? This idea of charges. So the SI unit, right, the standard unit for charge, is going to be coulombs, or C, right? So, and I just want you guys to know that the charge of an electron, right, is equal to negative 1.602 times 10 to the negative 19th coulombs. So, and a proton's charge is the exact same thing, just positive. So just keep that in mind. So now, another thing that you have to keep in track of is energy, and the SI unit of energy is just going to be joules, right? Or J. joules, right? J. And 1 joule, right, is equal to 1 Newton times 1 meter, right? Newton is just a measure of force, meter is a measure of distance, right? And there are two types of energies that, if you're listening to this, you should already have heard of before. One is kinetic, so energy of an object in motion, right? This ball is falling down and has some sort of kinetic energy. And potential. And it has this resting potential energy, right? And voltage is the electric potential difference between two different points, right? So it's the electric potential difference between these 2 points, right? So potential energy here. And the measure of voltage, right? 1 volt is equal to 1 joule over 1 coulomb, right? That's why I talked about the energy and the charge. And it's also known as, it's read as 1 joule of potential energy per unit charge. That's main physics definition behind it, like what exactly voltage is in terms of joule and coulombs. If you want me to go a bit more in depth for this, or if you have some questions, let me know down below in the comments. What I just want to end on is that voltage is just the more voltage you have, the greater your ability to push the electrons, right? That's why I was talking about my water pressure example, right? The more pressure you have, the faster the water will flow out. Thank you so much for watching, and if you have any more questions, please let me know down in the comments. My next video will probably be on resistance and current, or Ohm's law, so yeah, be on the lookout for that. And thank you so much again. See you next time.